This is our video for lesson 5.1, solving linear systems by graphing. So the first thing we need to think about is what is a system of linear equations? System is just two or more linear equations. And what it means to solve a system is to find one pair of values that makes both equations true. So what I mean by that is finding x comma y. So finding one pair of x and y values that will make both equations true. This will make a lot more sense once we just do this here in a second. So first thing we can do before finding solutions is we can just check solutions. So if I give you this 2 comma 5 and ask you, is it a solution? What we need to do is we need to plug in that x and y value and then see if it makes our equation true. So for example, this is x plus y equals 7. Our x value is 2, our y value is 5. So if we plug that in, that just means instead of x, I'm going to write 2. Instead of y, I'm going to write 5. And then I'm going to see if this equation is true. So is it true that 2 plus 5 equals 7? Yes, so we are good. So what that means is that this is a solution to the first equation. And if we were graphing this, what that would mean is this point would be on this line. So now we're going to move on to the second equation and see if it also makes this equation true. If it does, then we say that it is a solution to the system because it makes both of them true at the same time. So I don't need to rearrange this or anything. I know we oftentimes like to get it into like slope-intercept form. We don't need to do that because we're just plugging in those values and seeing if it is true. So I'm going to copy over everything exactly the same way as it is right now. It's just instead of x, I'm going to fill in my x value, which is 2. And instead of y, I'm going to fill in my y value, which is 5. So 2 times 2 is 4. Whoops, I don't know why I wrote 1 here. It should be negative 11. 3 times 5 is 15. So then is this true? 4 minus 15 is negative 11. Yes, that is also true. So again, we might say something like this if we were putting on this in words. So since 2 comma 5 makes both equations true, it is a solution to the system. Okay. So we're going to do the same thing here with part B. And this might be a good opportunity to try this on your own and then come back and just check your work. So again, x is negative 2, y is 0. We're just going to plug it in and see if that makes those equations true. So 0 equals negative 2 times negative 2 minus 4. So 0 equals 4 minus 4. True. 0 equals negative 2 plus 4. That is not true. This would be 0 equals 2. Okay, so this is not true. So we would say that this is not a solution to the system. Moving on, we can find solutions by graphing our equations. So when we do that, we're going to want to get it into y-intercept form. You could do it in point slope form as well. But generally, we're going to want to get it into slope-intercept form, meaning y equals mx plus b, so that we can just pick out our slope and our y-intercept and easily graph our equations. So we'll do the top equation here first. So my y-intercept is 5, so I know I have a point right here at 5. My slope is -2, so that means I'm going down 2 and over 1. Down 2 and over 1. Notice I could work backwards as well. I could go back 1 and up 2. Either way there works. And then we're going to draw a line through these points. And this is y equals -2x plus 5. And now we're going to draw our other line. Y equals 4x minus 1. So again, my y-intercept is -1. I know I have a point there, and my slope is 4x. So if that slope is 4x, that means I'm going up 4 and over 1. 2, 3, 4 over 1. So I've got a point right there. And there, and that should be plenty to get a nice straight line. There we go. So if we remember back earlier in the year, we said that, and just a second ago we said the same thing, that solutions to an equation are the points on the graph. Okay, so if I look at that blue line, the equation for this is y equals -2x plus 5. Every pair of x and y values that makes this true is a point on this graph. Every single one. That's what a graph is. It's literally the visual representation of all the solutions to this equation. So it makes sense then, if I find this point where these two graphs intersect, that is one point that is a solution to both equations at the same time. Okay, so that's what we're looking for when we graph. This point right here, which is 1, 3, is the solution to the system. Okay, so wherever those intersect, that's going to be our solution to the system. Just that easy. Moving on. Again, I would try this on your own. You're probably going to want to rearrange these equations a little bit to get them into that slope-intercept form. I'm going to go through it kind of quickly here. Our first equation, 9x plus 3y equals -3. So again, I'm going to want to get this into slope-intercept form. I think if I subtract 9x here, we should be getting in that direction. So now I've got 3y equals -9x minus 3. One more step will get me there. If I divide by 3, make sure you remember to divide every single term by 3. So we'll end up with y equals -3x minus 1. So there's equation 1. Equation 2, 2x minus y equals -4. Now, again, there's more than one way to go about this. If it were me, when I look at this, if I add y to both sides, now I'm going to end up with a positive y on the right, which is going to be helpful because we eventually need it to be y equals something. So let's do that. Plus y. Again, this isn't the only way to do this, but this is how I would do it. And then add 4 to both sides. And when I rewrite this, I'm just going to flip the y in front because that's the way we normally write this. Y equals 2x plus 4. Okay, so here's our two equations now. Let's graph these, see where they intersect, and that will be our solution. So y equals 3x minus 1. My slope is 3. So I'm going to go, slope is -3. So down 3 and over 1. Just like we did before, we can kind of work this in reverse order as well. And then we'll do the other one in red. Slope is 2. So we go up 2 and over 1. And as we see, our solution is going to be -1, 2. There we go. And we can always check our work too by plugging that value back into the equations, just like we did in that very first problem here. Moving on to our final example. We're going to solve this using technology. The key here is going to be just setting it up. How do we set this up? So our problem, a roofing contractor buys 15 bundles of shingles and 8 rolls of roofing paper for $640. In a second purchase, the contractor buys 8 bundles of shingles and 2 rolls of paper for $296. We need to find the price of a bundle of shingles and a price of a roll of paper. So the thing to remember when you're setting up the equations here, if we want to find the total cost of something, we need to take however many we've got times the price of each one, and that will give us the total cost. So we'll just need to pick some variables here. So I'll use the variable B for bundles of shingles. And what this is actually going to represent is the cost of one bundle. And for the roofing paper, I'll just use R. So this will be cost of one roll of paper. So we can start writing our two equations now, because if I'm buying 15 bundles, so I'm buying 15, so if I take 15 times B, which is the cost of a bundle, so if I'm buying 15 of them, 15B would represent that total cost, plus 8R, because that's the cost of a roll, equals $640. So this is one equation that represents our first situation. 15B plus 8R equals 640. And then we could write a second equation, because we've got the same variables, 8 bundles, 2 rolls. So now 8B plus 2R equals 296. And right now we're just solving this by graphing. So I'm going to want to put this into a program like Desmos or something. And Desmos is actually going to require us to use X and Y variables. So when you do that, you'll just need to change the B and the R. So we could write 15X plus 8Y equals 640. And 8X plus 2Y equals 296. And then we'll just have to remember that X now represents our bundles and Y represents our rolls. Actually, let me see if I can just do this real quick. Where is my Desmos? Go. All right, so let me see if I can remember here. 15x plus 8y equals 640. And then our second equation was 8x plus 2y equals 296. So if we just zoom out a little bit here, we can see where those two intersect, and Desmos is really nice because if you just click or point at that intersection, it's going to give you that solution. So 32 comma 20 is our solution. So 30 is the solution to the system, meaning that we'll make both true, and that's what allows us to figure out this price. So that means that a bundle is equal to $32. A bundle costs $32 and a roll costs $20. So the toughest part here, and I think students are generally feeling pretty good about this by the time they're at this point in the class, just writing these equations, punch them in using technology, and find the intersection.